How to diagnose RC motor issues, motor, ESC, or battery. Are you facing issues with your remote control vehicle and wondering where the problem lies? Is it the motor, the electronic speed controller, or the battery? Let's break it down step by step so you can get back to enjoying your RC hobby. First, let's start with the battery. Begin by checking the battery charge and voltage. Use a battery checker to ensure it is fully charged and holding the correct voltage. A weak or partially discharged battery can lead to power loss or sudden cutoffs. Next, inspect the battery connections. Make sure all leads and connectors are clean, secure, and free of corrosion. Loose or dirty connections can cause voltage drops, leading to performance issues. Evaluate the battery capacity and C rating as well. If the battery cannot supply enough current, the electronic speed controller may cut power to protect itself, causing the motor to start and then suddenly stop. Upgrading to a battery with a higher capacity or higher C rating can resolve this issue. Also, double-check that the battery is connected with the correct polarity. Reversed polarity can damage the electronic speed controller and cause failure. Labeling batteries can help prevent this mistake. Now, let's move on to the electronic speed controller. Disconnect the motor and power on the system. Turn on the transmitter and connect a fresh battery to the electronic speed controller. If it powers up normally, often indicated by beeps or LED signals, the electronic speed controller is likely functional. Check for proper programming and calibration as well. The electronic speed controller needs to recognize the neutral, throttle, and brake positions of your transmitter. Improper calibration can cause the motor not to respond or cut out unexpectedly. Inspect the wiring and solder joints for any damage, loose connections, or poorly soldered spots. Dry or cracked solder joints can lead to intermittent failures. If your electronic speed controller allows it, consider resetting or updating the firmware to fix bugs or erratic behavior. Look for signs of failure, such as no response, irregular beeping, or overheating, which may indicate that replacement is needed. Finally, let's check the motor itself. Start with a visual inspection. Look for physical damage, debris, or any burnt smell. Spin the motor by hand. It should rotate smoothly without grinding or resistance. Using a multimeter, measure the resistance between the motor wires. Significant imbalance or open circuits indicate winding damage. If possible, swap the motor with a known good one. If the replacement motor runs fine, the original motor is likely defective. Listen for any unusual noises during operation. Grinding, clicking, or irregular sounds suggest mechanical or electrical issues with the motor. To keep your remote control vehicle running smoothly, always use quality batteries and electronic speed controllers from reputable brands. Regularly inspect and maintain all electrical connections and components. Avoid overheating the motor or electronic speed controller by ensuring proper cooling and avoiding excessive current draw. Keeping the electronic speed controller and motor firmware up to date will also help maintain optimal performance. By following these steps, starting from the battery, then the electronic speed controller, and finally the motor, you can efficiently diagnose which component is causing issues in your remote control vehicle. This methodical approach will help you maintain your RC toy's performance and longevity.